So hi guys, so as I have already told you earlier, from this video we are going to start the series of activation function. Actually this is the second video. In the first video we have already talked about how activation functions work, why we need activation functions, what are activation functions. So we would start with it. So before that I would set the notebook to TPU for now, and yeah, if you want you can even you can go for GPU, but that is just some unnecessary stuff because we are not going to deploy any heavy model or any function here. We are just going to do some basics. We are going to understand about sigmoid function from today's video. We are going to talk about a lot of activation functions including ReLU, leaky ReLU and everything. So yeah, let's start with it. So basically what is sigmoid function? So the range of output which this function gives is between 1 and 0. As I've already told you, these functions help in normalizing the output. So this is it, and the range of the derivative is between -1 and 1. So this sigmoid function is the most frequently used activation function in the beginning of deep learning. If you are familiar with some basic of deep learning, that is CNN and TensorFlow, you must be knowing that I have used this sigmoid function in most of my previous beginning model videos. It is a smoothing function that is easy to derive. It can be thought of as a firing rate of a neuron. In the middle of as the firing rate of where the slope is relatively high, it is the sensitive area of the function, and on the other side where the slope is very gentle, it is the neuron's inhibitory area. So you can look at this. So if you look at the whole graph, you can see that the blue line, which is the normal sigmoid function, it is between 0 and 1. That is it. But this derivative of a sigmoid function, you can see it's a bit different. And I would like to tell you that the range of this derivative of sigmoid is between -1 and 1. So you must be thinking that how can we implement this sigmoid function. So this is the formula of sigmoid function, that is Sx is equals to 1 upon 1 plus e raised to the power minus x. I have already talked about that in the logistic activation function in the previous video. So we would simply first need to import three libraries, that is matplotlib to plot the graph, and the numpy, that is obvious, and the mathematic libraries. I would simply run this, and then I have defined that as x is equals to np dot line space minus 10, 10 and 100. We are using that randomly, not a particular values we have chosen. And then we are going to define the sigmoid function, that is z is equals to 1 plus 1 1 upon 1 plus e raised to the power minus x. So what we would do, np dot e to the power minus x. We would simply run this, and now we are going to plot x and z, and we are going to label that the x label is is the x, and the y label is obviously sigmoid of x. I would simply run this and plot dot show, as you can see. So this is how the function is working. You can see between 0 and 1, it's really obvious. We have provided it a lot of values, but you can see minus 10, 10 and 100. So at minus 10 you can see the value, and if you want to calculate at your it in your mathematical terms, you can use your normal pen and paper. But why to use it when Python has provided you some awesome libraries for that. So I would just run it once again, and if we want, we can even change some values. For here I would just do minus 10, minus 20, let's do that 20, and let's do that to 200. I would run this again and run this plot.show, and as we can see, the values have changed slightly bit, but yeah, it's always going to be stayed between 0 and 1. And don't you think this is going to help us a lot in classification and regression problems? So now let's look at another thing, another example, that is, let's define x is equals to np dot line space minus 100, 100 and 200, and z is equals to the formula, that is 1 upon 1 plus e raised to the power minus x. If you don't know about these mathematical exponential functions that we are using, I would recommend you to go and watch some basics of NumPy and mathematical libraries in Python, and I would simply plot this. So let's look at this. So yeah, you can see this is the x that we labeled it as x, and the y labeled as sigmoid of x. So you can see the values staying between 0 and 1, and the normalization has been done as following. The graph is going between 0 and 1, minus 100, then we set it 0, I guess, we get minus 100, and then we gave it 100, and then 200. So yeah, it's going according to that only. So now look at how to implement that in Keras. So if you want, you can go to the website. I have provided the link to the website here, and you can read all these things here. I have already explained. I will already explain that here. So the sigmoid function, activation function, can be defined as following: the sigmoid x is equals to 1 upon 1 plus exponential of minus x. Now this applies a sigmoid activation function for smaller values which are less than minus 5. The sigmoid function returns a value close to 0, and for the larger values that are greater than 5, the result would function would get the value close to 1. That's obvious. Now this sigmoid is equivalent to minus two element softmax, where the second element is assumed to be 0. Don't worry if you don't know anything about softmax, we would discuss that in another video. Just note the point for now. And the sigmoid function always returns a value between 0 and 1. So let's test it. So for obviously using Keras, we need to import TensorFlow. See, I would import TensorFlow as TF. And now let's define that a is equals to tf constant minus 20, minus 1.0, 1 and 20, and the t type has been float 32, and we are going to define that b is equals to tf.keras.activation.sigmoid. This is how we call the function here. We simply do tf, and from Keras APIs, from activation function, and from activation function particular activation functions, that is sigmoid one. If you want to use ReLU, suppose you want to use ReLU, you can simply do ReLU here. And the best part of sigmoid is it doesn't have anything external internal inside it. Suppose you see a lot of things are inside it, max value, threshold, and different things. Sigmoid is it's simple, not complicated. And we are going to define b is equals to the activation, the result of the activation function applied on a, and we are simply going to do b dot numpy. So I would simply do, yeah, and as you can see, the result is as following: that 2.0.6153 e raised to minus 9, and the results are going to be like that only. So you must be seeing that all the results are between 1 and 0, and this is how the whole function is working. Now let's look at the argument. It takes x is equals to input tensor and returns tensor with a sigmoid function activation, and the formula is as following. I have already told you 3 to 4 times. And let's look at some advantages and disadvantages. So the advantages are as following: the smooth gradients, it prevents jumps in output values. The output values bond is between 0 and 1, normalizing the output of each neuron, very beneficial thing. Now clear predictions that are very close to 1 and 0, 1 or 0, as I have already told you, values between minus 5 are going to be close to 0, and greater than 5 are going to be 1. So now let's see some disadvantages. It is prone to gradient vanishing problem and exploding gradient problem. If you don't know about that, don't worry. We are going to talk about these two problems that occur during machine learning in future. And the function output is not zero centered, and the power operations are relatively consuming. Yeah, so that is the reason we can use other functions also. But yeah, these 2-3 advantages we can't forget. So yeah, this is how we talked. I would just give you a brief summary. First, we look at what is sigmoid function, the graph of the sigmoid function. This is the formula. I would repeat it once again. Ssx is equals to 1 upon 1 plus e raised to the power minus x. You can say exponential also. And this is the graph. The output range of sigmoid function is between 0 and 1, and the derivative is minus 1 and 1. So yeah, and now we went to TensorFlow and Keras. The activation function would look something like this: that tf.keras.activation.sigmoid, and we simply put the value inside the defined function, the defined variable for sigmoid, and we simply plot it. So yeah, this is how the sigmoid function works, and I would provide you the link to this Google Colab in the description section. This would be a GitHub gist link, and you can go and play with this function, provide your own input values, and learn more about it. You can even go to Keras website and learn more in detail about how these functions are working, and even you can go through some Medium articles or data science articles. They are really awesome. Even I refer to them when I want to learn in depth about a particular thing in machine learning or neural network. So yeah, this was it for the video. I hope you have got an idea how sigmoid function works. In the future videos, we are going to talk about a lot of functions, including softmax, soft plus, and relu, leaky relu, and yeah, a lot of them are coming. So thank you and have a nice day.